G'day folks, thanks for joining us. My name's Byron, I'm a Security Solutions Architect based in Perth, Western Australia. You're here because security is a top priority. Today, I'm going to show you why using the AWS Well-Architected framework is one of the best things you can do to improve your security posture. Today, I'll cover off a number of well-architected best practices and highlight new features and content that were released over the last year or so that will help you implement them. We created the well-architected framework to help customers answer the question, funnily enough, am I well-architected? We answer that question by exploring the workload through 6 pillars that make up the framework. We start with operational excellence. How are customers operating in the cloud? Are they structuring teams and their ways of working in a way that aligns with how the cloud operates? We then focus on security, which is our top priority at AWS. Reliability, which is the workload's resiliency to failure. Performance efficiency. Are you matching the supply of resources to the demand for them? Cost optimization to avoid unnecessary costs. And last year, we added a sustainability pillar to help minimize the environmental impacts of running cloud workloads. Each pillar is made up of a series of design principles to help decision-making and a series of questions to focus the review. The questions have a number of best practices which are informed by those principles. Today, we are going to specifically focus on the security pillar and see how we can apply those best practices to a workload. This is an advanced talk. Before you apply the learnings from this presentation, review your security baseline. These 6 items here are the simplest steps you should be taking first. At the end of this presentation, I will have a link to a lab to help you implement these in less than half an hour. A well-architected review always focuses on a workload, a set of components including software, infrastructure, and the team supporting it that together deliver business value. Usually, a workload is at the level of detail that business and technology leaders communicate about. Today, I want to talk about my imaginary friend Kim's workload. Kim has a startup that has grown from a solo project to a larger team, and Kim is keen to ensure the workload is well architected, so the business can scale to meet the massive expected demand. Like many projects, the workload started as a monolithic application running on a single Amazon EC2 instance with a web application as well as a database on the same host. Amazon EFS is used for some data storage, and static content is served directly from Amazon S3. Kim also has some back-end processing triggered by Amazon SNS. On the side, I'm going to represent the questions in the security pillar. Kim and I have already run a well-architected review, and as you can see, things weren't pretty. Each of the questions is currently red. We want to make them green. This isn't going to happen overnight for Kim's team, so it's important to think of this as an iterative journey. Within each area, we'll look at quick wins as well as some longer-term projects for Kim to implement. Pointers to useful information to help you with your journey will appear in the bottom right. The list of content will be summarized at the end and as an attachment in the Summit platform. Let's go through each question and see what Kim can do to improve their architecture. The first area that the security pillar looks at is identity and access management. This can be divided into 3 considerations. Who, which is identity management, has access, which is access management, and to what, resource management. This is wrapped in an overarching governance. It's important to note that when we talk about identities, we are considering both humans and machines, internal and external to the organization, and resources at all levels of the application, including the AWS platform, the infrastructure layer, and the application itself. An AWS account is a coarse-grained container that we can start to deploy resources into. Rather than just employing a single account like Kim currently is, Kim is going to set up different AWS accounts for different purposes to isolate the components of the workload and control who has access at a very coarse level. Kim will then place an overall governance structure on top of this. Kim will set up an organization's management account to manage the structure and enable AWS organizations. AWS organizations helps Kim centrally manage and govern their environment as they grow and scale their AWS resources. Tools like AWS Single Sign-On will also be enabled here to create or connect workforce identities in AWS once and manage access centrally across their AWS organization. A best practice is to federate access from a centralized identity provider. This reduces the requirement for multiple credentials and provides an opportunity to integrate with HR's on- and offboarding processes. As part of this process, it's a good opportunity for Kim to rethink access permissions. Kim will limit which AWS accounts their team members have access to and will implement least privilege access to limit the services that users can access within an account. Here, we can see that Kim has given everybody administrator access. This worked well while getting started, but now that the team has grown, Kim wants to ensure that developers only have access to the services needed to deploy the application. AWS Identity and Access Management Access Analyzer helps remove unintended public and cross-account access by analyzing existing permissions. Last year, this functionality was extended to generate the least privilege policies based on activity within CloudTrail. CloudTrail shows who attempted to take what actions against AWS resources in an AWS account, and if the action was allowed or denied. So the generated policy will only contain actions that were actually undertaken by users. When generating the policy, Kim can choose the time period to base the access on, the CloudTrail trail to use, and the region the activity took place in. IAM Access Analyzer allows Kim to review the list of services and actions included in the policy, and allows them to review the policy before applying it. This is covered in a blog post for you to implement yourself. AWS Organizations allows accounts to be arranged in organizational units or OUs. Kim will create a security OU. In here, Kim will create a log archive account to centralize logs the security team may need. For example, access logs, DNS logs, or VPC flow logs, which are like network flow logs. Importantly, Kim is also going to turn on CloudTrail in the root organizations account to enable it across all accounts in the organization. Having a secure store of these logs provides the security team with an audit history. This archive is isolated and read-only. For teams performing security actions, a separate security tooling account is available where they will set up their security tooling and automated responses, isolated from the elements of the workload it is protecting. Another common OU that Kim will implement is an infrastructure OU. Here, tooling that needs to be shared between components, such as shared networking, can be set up. As part of this, the team is also going to implement build tooling to deploy their application. Separating development, test, and production environments into separate accounts ensures that developers don't have access to production data when they don't need it. This is facilitated by automating pipelines to deploy across multiple accounts, which will also ensure that the workload is deployed in a reliable and secure manner. If you want to go on the same journey as Kim, these aren't all systems you need to build out yourself. Consider using AWS Control Tower, which provides the easiest way to set up and govern a secure multi-account AWS environment. It creates a set of accounts using AWS organizations, brings ongoing account management and governance, as well as implementing best practices based on AWS's experience working with thousands of customers. Another starting point to build your environment is the AWS Security Reference Architecture, a holistic set of guidelines for deploying the full complement of AWS security services in a multi-account environment. There is an associated repository with solution patterns designed for the specific architecture illustrated in this reference architecture. Kim's architecture has evolved to include a range of identity and access management tooling, as well as some management and governance tools to manage accounts across the organization. As part of this, Kim has also removed long-lived credentials, replacing access keys and secret keys stored on EC2 with an instance role for access to AWS services, such as the backend processing triggered by SNS. Database passwords for each environment are now stored in AWS Secrets Manager, which allows access to be audited and passwords can be programmatically rotated. Kim has addressed the first three questions of the security pillar in the Well-Architected framework. Because Kim has spent time looking at identity and access management, Kim knows exactly who is doing what with each resource. When new people join the team or people leave, it's easier to maintain consistent access, and if an incident should occur, Kim now has some basic audit logging to understand what happened. The next area of the security pillar looks at detective controls. Detective controls are used to identify a potential security threat or incident. Kim is going to configure service and application logging and then analyze all logs, findings, and metrics centrally. Kim will start with AWS Security Hub, a cloud security posture management service that performs security best practice checks, aggregates alerts, and enabled automated remediation. Security Hub takes alerts from a number of sources, including Amazon GuardDuty, a threat detection service that continuously monitors your AWS accounts and workloads for malicious activity, Amazon Macie, a fully managed data security and privacy service that uses machine learning and pattern matching to discover and protect your sensitive data in AWS, and Amazon Inspector, an automated vulnerability management service that continuously scans AWS workloads for software vulnerabilities and unintended network exposure. Amazon Inspector was completely re-architected in 2021. Findings can now be delivered in near real time to minimize the time to discover new vulnerabilities. Kim can now enable Amazon Inspector across their entire organization with a single click and scan container images stored in ECR as well as EC2 instances. To intelligently prioritize vulnerability findings, the new Inspector introduces a highly contextualized Inspector risk score by correlating vulnerability information with environmental factors. Importantly for Kim, Inspector now uses the widely adopted Amazon Systems Manager agent for EC2 for vulnerability scanning, which was already introduced as part of the simplest steps for managing patching in the environment. Security Hub allows Kim to enable security standards powered by continuous automated security checks. The AWS Foundational Security Best Practices Standard is a highly curated set of security best practices vetted by AWS security experts that run whenever there are changes to the associated resource or on a set periodic schedule. Each control has a specific severity score and suggested action plan to help prioritize Kim's remediation efforts. Rather than waiting for the team to manually check for the new findings, Kim is going to create alerts that are sent to be actioned by the team. Findings are aggregated from all member accounts to the central security tooling account. Findings contain a lot of information, which can be used to automate actions. When sending findings to humans, though, we want to ensure that the alerts we create are actionable. To do this, Kim needs to ensure alerts include relevant information for the team to take action. For example, this might include augmenting alerts with additional information about the account that the finding was raised from. To do this, Kim can create a rule in Amazon EventBridge, giving them control over the routing and formatting of notifications. Security Hub consumes findings in a standard format called the AWS Security Finding Format. Once findings have been processed, additional fields will appear as user-defined fields. For this first step, Kim wants to filter on findings that have been imported and do not yet contain the enriched fields. These findings can be sent to AWS Lambda for enrichment. From there, Lambda can look up additional account information such as the account name, an environment tag, and who the account contact is from AWS organizations. Findings are then re-imported into Security Hub. We have a blog post covering off how to do this finding enrichment to help you. Kim will now use that additional information to create a more relevant filter, only alerting on high and critical events for the production environment. Using a simple notification service input transformer on the EventBridge rule target, relevant details can be extracted from the finding and then formatted into a friendlier message. This results in an alert that has clear, actionable information for sending via email, Slack, or whichever method makes the most sense for Kim's team. There is a sample on GitHub which details how Security Hub findings can be sent via email. Kim has now implemented some centralized detective controls, logging AWS API calls in AWS CloudTrail, application logs in Amazon CloudWatch, and network flow logs in VPC flow logs. These logs will be useful in identifying and responding to incidents. Kim has also started to protect their infrastructure and data by actively scanning for vulnerabilities and surfacing findings centrally in AWS Security Hub. Kim can now tick off another question in that well-architected framework. Defense in depth is a best practice in any type of environment. In the case of infrastructure protection, we want to look at how networking and compute is protected. With Kim, we want to look at how the team is enforcing boundary protection and monitoring points of ingress and egress. Both are essential to an effective information security plan. AWS has a dedicated security section to the documentation for many of the services. As Kim's team starts to use a new service, they can read the security section to understand what controls are available to them. By doing this, the team is aware of what actions they can take to secure the service. The AWS security documentation page here lists all the services that currently have a dedicated security section. Kim will leverage AWS Edge services to protect this workload, hosting the workload's domain records in Amazon Route 53, using Amazon CloudFront for content distribution, and using an AWS Web Application Firewall with some managed rules, adds a layer of defense at the edge of the workload. This also unlocks DDoS protection through AWS Shield. Even with just AWS Shield Standard on Amazon CloudFront and Amazon Route 53, Kim receives comprehensive availability protection against all known infrastructure attacks. Next, Kim will create different network layers to group components that share reachability requirements. To start with, the ingress to and egress from the VPC are separated so the team can set up connectivity to the other components based on whether they should be publicly accessible or just need internet access to update. Note here that each subnet layer has its own network access control list and route table, so the controls are specific to that subnet's purpose. At the application layer, Kim is going to separate the application itself, which executes code, from the database, which holds the state. The team will place the application in an EC2 auto-scaling group. As part of this, the team is going to have to look at defining the infrastructure as code for the application to ensure that the application can be reliably and automatically started in a known configuration. One way of achieving this is creating a golden Amazon machine image, or AMI, that contains everything the application needs to run. This will also allow the application to remain highly available during patching. When a new AMI is available, the team can rotate through old instances to terminate them and allow auto-scaling to bring up a new instance with the latest version. For the database layer, Kim is going to use the Amazon Relational Database Service and the Amazon Aurora engine, which is MySQL and Postgres compatible. Using managed services reduces the team's security maintenance tasks as part of the shared responsibility model. By separating the network layers and introducing protections for the compute layer, Kim now has better control over their workload at all layers, and Kim can now tick off 2 more questions in the security pillar. In this section, we saw the biggest changes in Kim's architecture. To illustrate this further, there are some specific labs available within the well-architected labs to demonstrate the concepts on this slide. If you want to dive deeper into the detail of deploying a best practices VPC and a best practice web application, make sure you check out those labs specifically. As an AWS customer, Kim maintains full control over their data. AWS makes it easier for you to encrypt your data and manage keys, which can be easily automated by AWS or maintained by you. In this area of the security pillar, we're concerned with ensuring data is classified and then protected in transit and at rest. Now that Kim has added CloudFront and an application load balancer, the team will use AWS Certificate Manager, or ACM, to enable encryption of data in transit. AWS Certificate Manager is a service that lets you easily provision, manage, and deploy certificates for use with AWS services. Anyone who has had to manage their own certificates knows that the renewal process can be frustrating. And even with the best laid calendar entries, if the deadline is missed, that can lead to an outage. Helpfully, AWS Certificate Manager manages the renewal process for the certificates managed in ACM and used with ACM integrated services. To protect the data at rest, Kim will use the AWS Key Management Service, or KMS. KMS makes it easy to create and manage cryptographic keys and control their use. KMS natively integrates into a wide range of AWS services. In Kim's architecture, KMS integrates to encrypt data at rest in the Elastic file system, on EBS volumes associated with EC2 instances, and for the Aurora database. Just encrypting everything in the same way because everything is assumed to be classified is an anti-pattern though. Without classifying data, you don't know what level of protection is actually needed for each type of data. For example, some data may be highly sensitive and require field-level encryption with tools such as the AWS Encryption SDK before it's stored. Once a data classification scheme is in place, Kim may want to use Amazon Macie to help discover and protect the data. Using a data classification scheme to correctly encrypt data in transit and at rest helps Kim tick off 3 more questions in the security pillar related to data protection. Kim now has better protection of their data, an important asset for the business. However, one more principle for Kim to consider is ways that people can be kept away from data. Using mechanisms and tools to reduce or eliminate the need for direct access or for manual processing of data reduces the risk of mishandling or modification when handling sensitive data. Kim has already partly achieved this with the multi-account strategy implemented earlier. Separating development, test and production environments and restricting access keeps developers away from production data. Kim will take this a step further by automating the use of Macie to identify data where it shouldn't be. Kim has been planning to implement a data lake for some advanced analytics. With the product taking off, they're now looking at implementing this using the S3 bucket here to store the data. In this monitored bucket, they don't need sensitive information though. They only need anonymous data for calculating their analysis. So, how can Kim use Macie to automatically protect customer data? Well, when Macie creates a finding to say that sensitive data has been identified, a rule can be triggered in EventBridge. A Lambda function can then handle the finding and send a notification to Slack, so the end user is alerted that sensitive data has been incorrectly transferred to the bucket. The user can then respond in Slack to trigger an automation through API Gateway and Lambda to remediate the issue. Lambda can remove the data from the monitored bucket and copy it to a quarantine bucket for later investigation. The Lambda function can then send another alert to Kim's team via Slack to confirm that it's been done, all without anyone having to see the data. To speed up this process, the finding handler could even directly call the remediation function, further reducing the time to respond. If you want to implement this pattern yourself, I've linked to a blog post at the end of this talk outlining the steps to take. Even with the preventative and detective controls already put in place, Kim still needs to put in place processes to respond to and mitigate the potential impact of security incidents. Whenever a detective control is implemented, a corresponding response should be formulated at the same time. As part of implementing the detective controls, Kim turned on Amazon GuardDuty. GuardDuty takes in data from VPC flow logs, DNS logs, CloudTrail events, which as a reminder is an audit history of most AWS API calls, and S3 data plane events. GuardDuty then uses threat intelligence to create heuristic-based alerts, such as when Bitcoin mining or command and control activity is happening within Kim's infrastructure. It also creates alerts based on anomalies detected by machine learning. For example, if a user performs actions they don't normally perform, or accesses AWS in a different manner than they usually do, maybe from a different location. These findings are then prioritized and can be used to alert and respond to. Using the list of available detections and creating a playbook to respond to each of them is a great starting point for Kim's team to build the team's incident response capability. Playbooks don't have to be complex. They can be as simple as a text markdown file that outlines the scenario and the expected next steps. In the example here, what does Kim want the team to do if they find suspicious activity on an EC2 instance? There are some logs to gather to see what happened and some next steps to investigate. There's an escalation path to ensure the incident can be resolved and some simple resolution steps to contain the incident. Kim and the team can then take these playbooks and run an event simulation to practice them and ensure they're correct. The good news is you don't have to start from scratch. We have a number of incident response playbooks available on GitHub to get you started. Ideally though, Kim doesn't want to get woken up at 2 a.m. to respond to incidents. Once the response is known and tested, it can be automated. Kim's team have already aggregated findings from all accounts into the security account, so there's a single place the security tooling can be expanded from. New findings in Security Hub can trigger an event bridge rule, as we saw earlier. The playbooks can be codified in tools such as AWS Lambda or AWS Step Functions. Step Functions is a low-code visual workflow service that can be used in this case to automate the response process. Step Functions manage failures, retries, parallelization, service integrations, and observability, so Kim's team can focus on the higher value response logic. Using a pre-provisioned cross-account role that only trusts the security account, the playbooks can assume this role to run automations in AWS Systems Manager to respond to the finding and remediate it. On completion, the playbooks can then alert Kim's team that the event has already been mitigated, and the team can investigate next steps when they wake up. This means that the incident has been mitigated without having to wait for somebody to log on, find the correct playbook, and then respond. Automating containment and recovery of an incident reduces response times and the organizational impact. The example here is based on the AWS Security Hub automated response and remediation solution available on our website. Starting with the findings available in GuardDuty as the basis for creating playbooks builds the team's initial incident response capability. By running event simulations, the team can confirm that they have the right tools and access to respond to events, which means that Kim has now evolved the workload to a point that all the questions in the security pillar have been answered and the workload is well architected for security. The evolution of this architecture doesn't happen overnight, and it is an iterative journey. For each of the questions, I started with some quick wins for Kim and then provided another iteration for additional security. Over the course of this talk, I've highlighted new features and content that have been released over the last year or so to help you with your next iteration. But that isn't the only content that is available. At AWS, we are continuously releasing new guidance and new solutions to help you evolve. The most important thing is to start today and then to continue to iterate throughout your journey. Just like Kim, you are able to perform a well-architected review against your own workload. The well-architected framework is available as a set of white papers outlining the best practices and as a tool in the AWS console to perform a review. For a successful review, you will want to make sure that you have your own Kim in the room, someone who will drive the remediation of the highlighted risks. I've even seen teams use a well-architected review as a mechanism to get additional time or funding for remediation. You'll want to ensure that the whole team is present. This ensures that the questions can be answered in enough depth to be accurate and actionable. Lastly, remediate the risks and use the milestones in the tool to watch how the highlighted risks are remediated over time. To get you started, here are some QR codes to the content covered in this talk. You should also be able to find the content by searching for the title. In the Summit platform, these links are available as an attachment. Start with the well-architected framework. Use the labs to enable your team and then look at each of the areas from the security pillar. Identity, to ensure that only authorized and authenticated users and components are able to access the resources in the manner you intend. Detective controls, to identify potential security threats or incidents. Infrastructure protection, such as defense in depth, to meet security best practices. Data protection to secure your data, and incident response to ensure your organization is ready to respond to and mitigate the potential impact of security events. AWS also has a number of training options to get started with your cloud training and certification. Thank you for taking time to join me today. Remember, security is a continuous journey and the best time to start is today. Before you go, don't forget to fill in the session survey to ensure we can continue to bring you content to help you stay secure.